There are over 100 billion stars in our galaxy. Most of those stars have planets. Many of those planets are Earth-like. And the universe has been around for over 13 billion years. So, where is everybody? This simple question, famously asked by physicist Enrico Fermi over lunch in 1950, has become one of the greatest scientific and philosophical mysteries of all time. It's known as the Fermi Paradox, and it asks, if intelligent life is likely, and the universe is so old and so vast, why haven't we encountered anyone yet? Today on Infinite Mind, we're diving deep into that silence and exploring the unsettling, fascinating, and sometimes terrifying reasons why we might be alone, or why we haven't noticed that we're not. At first glance, the logic seems airtight. Take the sheer number of stars in the Milky Way. Estimates put it around 200 to 400 billion. Now, thanks to recent breakthroughs from telescopes like Kepler, we know that most of these stars have planets. In fact, many have multiple, leading to an estimate of over 100 billion planets just in our galaxy. And among those, at least 40 billion are believed to be Earth-like. That is, rocky, within the habitable zone of their stars and potentially capable of supporting liquid water. Statistically speaking, the ingredients for life, carbon, water, energy, are everywhere. Then factor in time. Earth formed about 4.5 billion years ago, but the universe itself is nearly 3 times older than that. That means there could be civilizations that formed billions of years before us. Civilizations with a massive technological head start. So if the math supports it and the timelines support it, then again, where is everybody? This is the Fermi Paradox. One tool scientists use to approach this riddle is called the Drake equation. It attempts to estimate the number of detectable alien civilizations in the Milky Way based on factors like star formation rate, the fraction of stars with planets, the number of planets that could support life, the odds of life developing, and the lifespan of advanced civilizations. Depending on how optimistic or pessimistic you are with the variables, the number it spits out ranges from 0 to millions. But here's the weird part. No matter how generous we are with our estimates, we still have no hard evidence of intelligent extraterrestrial life. No radio signals, no alien artifacts, no spacecraft zipping through our solar system. Just silence. So what gives? Scientists and thinkers have proposed dozens of theories to explain the Fermi Paradox. Let's go through the most fascinating ones. First, there's the idea of the Great Filter. This theory suggests that at some point between the formation of life and the development of advanced civilizations, there's a massive, almost impassable barrier, a cosmic wall, something that stops life from progressing, either often or always. That filter could be behind us. Maybe life is incredibly rare and Earth is a freak accident. Or it could be ahead of us. Maybe the natural trajectory of intelligent life is self-destruction, nuclear war, climate collapse, AI gone rogue. Whatever it is, no one makes it past that point. If the Great Filter is behind us, we might be incredibly special. If it's ahead of us, we're in trouble. Another possibility is that aliens are already here, or at least watching. This is known as the zoo hypothesis. It suggests that advanced civilizations do exist, but they're deliberately avoiding us. Think of Earth as a cosmic nature reserve. They observe us quietly, waiting until we're evolved enough, mature enough, or non-violent enough to make contact. This idea might sound like science fiction, but it echoes human behavior. We often study animals without interfering, especially when we fear disrupting their natural development. A more extreme version of this is the dark forest theory, popularized in Liu Cixin's novel, The Three-Body Problem. In this scenario, the universe is like a dark forest, where every civilization is a silent hunter. Because the moment you reveal your location, you risk annihilation. After all, if you don't know another species' intentions, isn't it safer to stay quiet or even strike first? Maybe everyone's hiding, including us. Then there's the too early hypothesis. Maybe we're one of the first intelligent civilizations in the galaxy. Maybe the conditions for life, while common, just haven't had enough time to evolve intelligence elsewhere. We could be the pioneers, not the latecomers. Or it could be the opposite. Maybe civilizations arise, but don't last long. Maybe intelligence is fleeting. Species rise, build, explore, and vanish, leaving no trace behind. If that's the case, the silence isn't mysterious. It's a graveyard. There are also stranger possibilities. Some theorists suggest that alien life may be so fundamentally different from us that we wouldn't even recognize it. They could be non-biological, machine-based, energy-based, or existing in dimensions we can't perceive. We're looking for radio signals and carbon-based biology. But what if they communicate through neutrinos, or live inside stars, or in universes adjacent to ours? We might be scanning for fingerprints, when the real clues are shadows. There's also the idea that we're inside a simulation. In this case, the silence isn't natural, it's programmed. The creators of our simulated universe may have decided to limit us to one lonely civilization, either for observational control or dramatic effect. If you're the only conscious player in the simulation, extraterrestrial silence isn't a paradox. It's by design. So what does all of this mean? If we're alone in the universe, truly alone, then life is unimaginably rare. That would make Earth and every living being on it profoundly special. It would also mean the responsibility to preserve and protect life falls entirely on us. There's no one coming to help, no galactic council, no second chance. We are the caretakers of consciousness in a vast, indifferent cosmos. But if we're not alone, and the silence is intentional, that might be even more terrifying. It means we're being watched, or ignored, or kept in the dark for reasons we don't understand. Maybe we're not ready, or maybe we're dangerous. In either case, the silence is meaningful. The Fermi Paradox forces us to confront our deepest questions. Who are we? Why are we here? Are we a cosmic accident, or a deliberate outcome of a larger pattern? And perhaps the most important question of all, what happens when, or if, that silence breaks? Because one day the quiet may end. Until then, we listen.